Our next speaker is Stan Litras, and Stan is a dentist in private practice in Wellington. He's been president of the Wellington Dental Association and on the board of the New Zealand Dental Association.
Yes.
Yes. So,
I've actually resigned from the Dental Association recently.
You were a member of the international expert panel of scientists and medical professionals who made the critical analysis of the 2014 New Zealand Fluoridation Review conducted by the Royal Societies.
I don't consider myself an expert, but I contributed to it.
You contributed. Anyway, this is Stan, and welcome.
Just to get it right. Don't want to be accused of misrepresentation. Hello everyone, it's great to be here in beautiful Sydney, and it's an honour to be presenting to an enlightened audience as you are. At Otago Dental School in the 80s, I was told that water fluoridation reduced tooth decay greatly, and I always held that opinion without really being able to justify it, except to quote some early studies that I was taught, and to have the warm fuzzy feeling that it was endorsed by the Dental Association. A couple of years ago, I decided to look at the evidence in person, as I thought my opinions should be based on evidence rather than endorsements. Water fluoridation is all about reducing tooth decay. There's no other reason to be doing it. But how do we know that it's working? Decades of research in this area has been unreliable due to poor design and bias. But as the saying goes, the proof of the pudding is in the eating. So what benefit are we seeing in today's communities? The New Zealand data gives us an opportunity to look at communities with and without water fluoridation and quantify the level of benefit in real life. I will look at decay trends, current New Zealand data, interpretation of statistics and how it stacks up with our current understanding of how fluoride works. And just to stress, I in no way represent the opinion of the New Zealand Dental Association, or probably the majority of dentists in New Zealand who have opinions, but continuing. This Christmas I went on a road trip up the central North Island. I happened to pass through Hastings and came across this cheerful group of citizens on the roadside. I'm pictured there with them. I stopped to ask what was happening, and they said they were celebrating their new fluoride-free water tap, pictured there, which their council had installed to cater for the residents who didn't want fluoridated water. Hastings was the first New Zealand town to have their drinking water topped up with artificial fluoride back in 1954 as part of a human trial, and many citizens have been struggling with it ever since. So these guys were happy because now the 40% of the people in Hastings who don't want fluoridated water coming out of their taps just need to hop in their car, drive across town with a few plastic bottles, join the queue, fill them up, drive back home, and then they can make their brew, boil the spaghetti, or perhaps even brush their teeth. I hope you're understanding the New Zealand accent. Yes. Thank you. Good luck with the cricket, by the way. I could understand if these people were a bit peeved at having to go to such an effort, especially considering that after 60 years of fluoridation, the dental condition of Hastings residents is no better than those of neighbouring Napier 10 kilometres up the road, which has never been fluoridated. So it's reasonable to ask the question, how much benefit do we get from fluoridating the water? The most trustworthy review of the scientific evidence was the York Review conducted for the National Health Service in the UK and published in 2000. It found that there was a 15% reduced incidence of decay in fluoridated areas. They found that the research, however, was generally of a very poor standard of reliability. Out of 3,500 studies, they only considered 26 were up to scratch. And it emphasised that the findings could be inaccurate due to poor controls for bias and dental age. New Zealand and Australian research since then have similarly failed to control adequately in these areas and seem to lack objectivity. Efforts are currently being made to set guidelines for oral health research to overcome the lack of transparency, bias and misrepresentation which has been occurring in this field. It is to be hoped that New Zealand and Australian dental schools will comply with such guidelines. One study which does follow the York Review requirements for reliability, which Paul mentioned earlier, was the Iowa study in the United States, which was a longitudinal study with a sound design. It finds that tooth decay is not related to fluoride ingestion, and there is no benefit from water fluoridation. The same level of benefit, none, was demonstrated by the largest US study of school-aged children, as reported by Yamuyanis. Tooth decay has dropped dramatically in recent decades, as shown on this graph of the average number of decayed, missing and filled teeth in 12-year-olds, with the blue line representing the New Zealand data since 1960. This is mirrored by the Aussie data in green underneath. The drop corresponds with the start of water fluoridation. And enthusiasts might jump to the conclusion that the large drop in tooth decay is because of water fluoridation, and in fact many do. Some even climactically proclaiming it one of the greatest public health measures of the 20th century. But there are some glaring flaws in this cause and effect theory. First of all, the reduction of tooth decay with time, shown by the red arrow, indicates that the drop has not occurred just in fluoridated areas alone, but must have also happened in unfluoridated areas, considering that only 50% of New Zealand has ever been fluoridated. The second bug in the ointment is that the decay levels have been dropping in New Zealand at the same rate since the 1930s, well before water fluoridation was implemented, as shown in this graph by the late Dr. John Calhoun. In fact, we can see no difference in the rate of decline after the introduction of water fluoridation to half of the country. The third bug in the ointment, actually it's an elephant in the room, and you've seen versions of this graph earlier, is that tooth decay around the world has dropped just as much or more in countries which do not have water fluoridation. In this graph we can see that the decay has dropped no faster in New Zealand and Australia than in countries with no water fluoridation, such as Germany, Japan, Denmark, Netherlands, Sweden and Iceland. Here, countries are ranked according to DMFT in 12-year-olds, with Denmark at the top having the best figure of 0.7 of a tooth affected by decay by age of 12. And down the bottom, we see Norway with 1.7 teeth. Only a handful of countries fluoridate their water, and this is shown in green, with the amount of green representing the proportion of the population in each particular country with water fluoridation. The only country with mandatory water fluoridation, Ireland, ranks 10th. Australia, with 80% fluoridation, is 8th, and New Zealand, with 50% fluoridation, comes in at 18th out of 20. Note that only one country out of the top 7 use water fluoridation, England, which is only 10% fluoridated. A few countries use salt fluoridation, shown proportionately in green. Salt fluoridation is cheaper than water fluoridation and does not undermine human rights in the same manner. In New Zealand, government healthcare is administered regionally via district health boards, which are shown in this map. The health boards run the free dental school service, which attends to about 90% of Kiwi kids. Decay data on 5-year-olds and school year 8s, which equates to 12 and 13-year-olds, is collected annually and published on the Health Department website. The spreadsheet lists the DHB regions on the left, and the data on numbers, percent, caries free and DMFT are set out in blocks with the total, fluoridated and non-fluoridated, and the data is also broken down by ethnicity, which I haven't shown here. Looking at the last 20 years, there hasn't been much change in the decay rates. This shows the non-fluoridated DMFT from 1990 to 2011, year 5-year-old and year 8, and this is the fluoridated. So it's been pretty constant. I'll be looking at more detail at the 2011 data. The 2012 data had a few problems and it is incomplete. The 2013 data was only released a couple of days ago. It shows no particular difference to what I'm going to be saying. When we compare data from fluoridated and non-fluoridated areas, we need to keep in mind a number of possible underlying factors. For me, the most important one is how long the teeth have been present in the mouth. This is something that's ignored by most comparative studies. The longer the teeth have been in the mouth, the more chance they've had to decay. We know that factors can affect this, such as different ethnic groups. For example, Maori and Pacific Islanders get their teeth up to a year earlier than Europeans. So we could expect them to have more decay at a particular age. There's also evidence that drinking fluoridated water makes teeth come through later in life, perhaps because of the melatonin effects that Ray was talking about earlier. In New Zealand, there are proportionally more Maori in the north and also rural living, which can affect decay data due to factors such as earlier eruption times, diet, socioeconomic status and education. Furthermore, towns with higher Asian populations, such as Auckland, would trend lower, as Asians tend to have lower decay rates. With that in mind, let's look at the latest set of complete data, 2011. We see that the more fluoridated cities are in the North Island, and we see the more unfluoridated centres, Christchurch, Nelson Marlborough, are in the south. They certainly don't appear to be lagging behind. In fact, if you look at counties Manukau, with 5,500 fluoridated 5-year-olds, the decay incidence and severity is among the worst in the country, despite being fluoridated. And the DMFT data for 5-year-olds in urban centres show there is no obvious difference in the severity of tooth decay. Again, counties Manukau, fluoridated, is way out in front of the pack in the decay stakes. In the 12-year-old age group, again, there are no obvious differences, nor in the DMFT. To reduce possible regional variation factors, we can look at individual regions with comparable populations of fluoridated and non-fluoridated children. If we do this, we find, again, no particular pattern by fluoridation status, with some regions having more 5-year-olds with cavities in fluoridated areas and the other way around in other regions. In science, you need to ask serious questions if a result is the opposite to that predicted by a theory, and the theory does not hold in 50% of the cases. From this data, it is obvious that this theory is being constantly challenged. Einstein is reported as saying that if the facts don't match the theory, then change the facts. This is more difficult to do when looking at data from large communities. Again, there's no clear pattern in the 12-year-old figures. If we look at the intra-region DMFT figures for 12-year-olds, there's possibly a small advantage towards fluoridated areas, showing the 12-year-old DMFT figures, but this is probably a reflection, in my opinion, of delayed tooth emergence factors in permanent teeth. So I just have to make sure that matches with this. Okay, so let's put it all together and look at the total New Zealand figures, the overall country. We see that the absolute difference in 5-year-olds between fluoridated and non-fluoridated areas is less than 1%. Clinically, you would need to look at 140 children in each group before you found an extra cavity in the non-fluoridated group. In 12 and 13-year-olds, the caries-free difference is around 3.5%. It means you would discover an extra decayed or filled tooth every 30 children. The severity of decay is indicated by the DMFT figures. Now here we see a difference of 0.13 in a 5-year-old. Now it's important to understand that DMFT is a cumulative measure. That is, it hasn't just happened overnight, it's taken 4 or 5 years to show this difference. By the age of 5, teeth have been in the mouth for up to 5 years. The yearly increment could therefore be calculated as 0.1 of a tooth. . And in the year 8, the clinical significance of this difference is 1 tooth, extra tooth every 30 years. Now the New Zealand Health Department position is this.
My name is Robin, Dr. Robin Haseman Welsh. I'm the Chief Dental Officer for the Ministry of Health. I'm a registered dentist, a wife and a mum. I drink fluoridated water. The most recent national study, the 2009 New Zealand Oral Health Survey, showed that on average, New Zealand children had 40% less tooth decay when they were living in fluoridated areas compared to non-fluoridated areas.
Now, Robin is a very charming and professional dental health colleague, who I find most approachable in discussions. She's highly competent at implementing the DHB policy. I'm concerned, however, that the benefits are overstated and are not based on objective advice. The problem is that the 2009 New Zealand Oral Health Survey was not designed as a scientific study into oral health status of people by fluoridation status, as it says there, and did not control for confounding factors by its own admission. To use this in making public health policy is therefore very inappropriate. The 40% figure quoted comes from this table, in the 2009 New Zealand Oral Health Survey. It is the relative difference when you compare the mean DMFT of children aged 2 to 17 by fluoridation status of their current residents. Note also that the relative difference over all age groups is much less, falling to about 20%. This evidence supports observed cross-sectional age group comparisons may be reflecting delayed decay experience rather than prevention. According to the 2009 oral health figures, children living in unfluoridated areas have an average of 2.4 teeth with decay experience in the age group up to 17 years old, compared with an average 1.5. Now there are 28 teeth present, and that's why my graph looks a bit funny, because I've shown the relative amount of teeth in the mouth. So the absolute difference of 0.9 of a tooth out of 28, or about 3% by age 17. Overall, over all the ages surveyed, ages 2 to 74 years old, the data of the Oral Health Survey shows an average lifetime difference of 2.5 teeth DMFT by fluoridation status. The other finding of the New Zealand Oral Health Survey, however, shows that there has been no improvement in lifetime decay experience following introduction of water fluoridation, the way that I'm reading it, with the 65 to 74-year-olds in 2009 having exactly the same number of decayed, missing and filled teeth as the age group had in 1988 and in 1976 even. This data again suggests that the effect of fluoridation is simply to delay tooth decay as opposed to preventing it. The data I presented indicate that if you account for potential confounding factors of research bias and retarded tooth eruption in fluoridated areas, as identified in the York report, community water fluoridation is probably of no clinically significant benefit to decay reduction in developed countries. So is it possible that decay reduction previously attributed to community water fluoridation was actually the result of other community and lifestyle factors, and that a myth has been knowingly or unknowingly perpetuated by enthusiastic dental researchers who have succumbed to bias in representing the reliability of their research to public health authorities? Is endorsement of the beneficial effects of community water fluoridation a case of the emperor's new clothes syndrome? We now agree that the theory held for 50 years that swallowing fluoride during tooth development was barking up the wrong total treat. There is now no argument, oh geez, sorry, I forgot the slide, guys, there you go. There is now no argument that the action of fluoride is a surface contact effect, and the fluoride incorporated into teeth during development does not make them more resistant to plaque acids. The only reason left to justify swallowing fluoride is the hope that it might raise salivary concentrations to a level that can slow down an early cavity. The whole argument rests on whether the levels attained are high enough. The research indicates they are not, and this was conceded by the leading promoter of fluoridation, the CDC, in 1999, who stated that this concentration of fluoride is not likely to affect carcinogenic activity. It would appear that while drinking fluoridated water was considered a better than nothing hit and hope method 50 years ago, with the widespread availability in countries such as Australia and New Zealand of fluoridated toothpaste from the 1980s and increased fluoride in the food chain, dental materials, drugs, its questionable usefulness is redundant, and responsible health authorities and politicians, faced with mounting evidence of health risks and dwindling evidence of efficacy, have only one option in the public interest, and that is to stop putting artificial fluoride in the water supply. It would appear that the European Union Committee of Science, Health, Environmental Research, who report no obvious advantage appears in favour of water fluoridation compared with topical prevention. The effect of continued systemic exposure is questionable. This suggests that water fluoridation plays a relatively minor role in the improvement of dental health. Last one. Should we be making such important decisions about health based on propaganda? I ask you to give your own consideration to this, and I thank you for your time today.
Okay, well, are there any questions? Simon, you do deserve a question. This is Simon de Pomeroy, who's helped us help organise this, and without Simon this would not have happened.
Thanks, Simon.
Stan, the figure of 40%, the relative saving of 40% that used the young age group rather than any other age group, or the combined average of which would have given 20% reduction. Has that been put to these people who came out with that information, and do they have what's their response to that? I mean, I'm sure that they've been questioned about it. What do they say about the quote of 40%?
Yeah, it's hard to find them to talk to about it, to be honest. No, it's a statistical play that they do for PR. They realise that that doesn't translate into saving tooth decay or improving oral health to any great degree, which is what I tried to show with the figures. It's a statistical illusion.
Stan, it's actually a really common use of research. I mean, the difference between relative and absolute is commonly, if I said to you, take a statin drug and it will reduce your chance of getting a heart attack by 40%, you or any doctor who didn't prescribe it for you, you'd have to be considered negligent. But if I said to you your chance of getting a heart attack was 3 in 100, and your chance of getting a heart attack after you took statin was 2 in 100, you might go, well, now hang on, that's not really worth it. And that is a very, very common, this is why this, the world of evidence-based medicine, you're probably getting a sort of a hint of this, aren't you? A research article clearly shows one thing, and another research article clearly shows another thing, and what the hell is going on? And unfortunately, the way research is, I mean, there's the whole thing about methodology, number one. There's the whole other thing about being totally preoccupied with controlling one variable at a time. You heard Paul say the gold standard was a randomised control study, which is perfect for showing that a placebo drug is better than another drug. But in the real world, one thing, it's not ever just one thing. So we've got a problem with the randomised control study being the gold standard, applying that to human health, and we've got another problem in that the evidence-based medicine has become evidence-based marketing because of the way relative figures are used when it should just be absolute figure. The absolute figure is not very impressive, but 36% or 40%, it's a common ploy used in a lot of research. Did you want to have a question?
Maybe a bit trivial, of no interest to anybody, but when I lived in Gisborne, obviously they didn't fluoridate the water. One of the engineers got his kids to take fluoride tablets. This is the only time I've ever heard of any such thing, but is that a common practice?
Yeah, it used to be recommended by the health department for children not living in fluoridated areas. They're not recommending that anymore because the evidence is showing that swallowing fluoride tablets does not improve dental health. That was in the days when they thought it made teeth stronger before they come through into the mouth. All that swallowing fluoride tablets does now is increase the potential for health problems, and so they realise that, and they're not recommending it any longer.
Yeah, I can just add to that. I was born in 1959 in the Crown Street Women's Hospital, not far from here. My mother chose to bottle feed, personal choice, and she was sent home from the hospital with fluoride tablets for my bottles. 1959, that was pre-fluoridation in Sydney. Oh, I have some dental fluorosis as a result of that, and I'm not pleased.
Hopefully that's all.
Okay, are there any other questions? Charles, just bring that up.
Sorry, I keep on having to play devil's advocate today.
Pleased to hear from you. I was expecting a question.
Yeah. The data you showed just showed non-fluoridated versus fluoridated regions of New Zealand. Have you converted that data to what the actual fluoride content is of the water, and does it look similar?
Yeah, the naturally occurring fluoride in unfluoridated water over just about the whole of New Zealand is 0.2 parts per million. The places that do fluoridate now use 0.7 on the whole. Sorry, was that your question?
So the non-fluoridated part,
the non-fluoridated would have 0.2 in their water. 0.05, which is actually quite a lot when you're looking at the daily ingestion of fluoride and intake, the diet intake into account as well. In my opinion, we're getting in New Zealand and in Australia, because they're very similar, we're getting heaps of fluoride in our diet anyway, and given the concerns, adding it to the water is it's sort of a bit encouraging the overdose factor for no particular benefit.
I'm going to play devil's advocate as well.
Yeah.
You showed multiple slides there that appeared to show no difference, fluoridated versus unfluoridated, but then the latter slides did show a difference, that the fluoridated water people did have lesser tooth issues. Then I suppose that your argument was that there are other compounding factors that could explain that.
Mainly delayed tooth eruption in fluoridated areas. There's evidence showing that teeth come through later in kids in fluoridated areas, so they haven't had as much opportunity to decay, and this is more noticeable in permanent teeth. Delaying factors, someone might know better about that than me, but in primary teeth it's more a factor of the bone density being harder, so it's harder for the baby teeth.
Is that, in your opinion, a complete explanation of the difference, if you like? I suppose what I'm getting at is the bottom line to all of this, the counter argument is, does fluoridating the water reduce the possibility of tooth decay in any way? That's A, and then B, obviously the decision as to whether that benefit, in inverted commas, is outweighed by the fluoridation negatives. What I really want to know is, does or does it not make a difference to tooth decay in any way, even if it's 0.1 of a tooth?
Right.
In your opinion, and the opinion of the rest of the panel, I suppose.
Well, as I showed in the data, if you put the confounding factors aside, you could expect to save maybe 2 fillings in your lifetime. The confounding factors, which I had the slide of, I won't go back to it, quite a lot. And a large confounding factor is the way the research is done and the way that data is collected. For example, the Hastings Napier study that they did in New Zealand, I don't know if you've read much about that, but that's what got the ball rolling. They compared Hastings and Napier. They were like twin towns next to each other. Everything else was supposed to be the same. They put fluoride in Hastings water, and they were watching it for 10, 15 years, they found no improvement in the tooth decay compared with Napier. In fact, Napier tooth decay improved without fluoride. So then they changed the design of their study and they said, we won't make it a comparison study anymore, we'll drop Napier off. And they just looked at Hastings. And then Hastings still didn't drop, and then they brought in a new lead researcher who had worked in this field in the United States studies, and overnight, more or less, they found a sudden drop. Well, a large explanation for that drop, which they didn't mention in the study, was that the health department advised the school dental nurses not to do unnecessary fillings. That immediately improves your DNFT rate. Back in the, 60s, it used to be considered preventive treatment. I don't know if they did it in Australia as well, they probably did. They would grind out the grooves on the kids' teeth, the fissures as we call them, and fill them up with mercury amalgam fillings because they considered that was preventing them from decaying. It made them easier to clean, they were smoother.
That's true, because when I was at university in the 70s, there was just the tail end of a concept called extension for prevention.
Extension for filling the valleys. They call it filling the valleys, very infamous.
Because you knew, and you know, you knew that decay was going to be rampant, well, that was what was happening, and so you were taught to the concept of extension for prevention.
And I've seen directives published in their Gazette as the way that the health department put the instructions out to school dental nurses who worked for them, and they directed them to be more preventive from now on and not to, go around doing these unnecessary fillings. That coincided with the improved decay rate as shown by water fluoridation, so that's quite a coincidence. But there are a lot of factors that come into the figures, and I think, given that the health department and the interests that will favour the promotion of water fluoridation actually control all this data and the people recording them, I think a difference in one age group of about 3 or 4%, which appears to be consistent in the areas I looked at, is not that convincing.
Are there any other questions? Okay, thank you, Stan. Thank you.